There are three main types of control structures in programming languages that dictate the flow of your program. These include sequential, selection, and repetition. In sequential, commands are executed in sequential order. For selection and repetition, a conditional expression is evaluated, and the commands that are executed next depend on the outcome of that conditional expression, and a conditional expression should evaluate to true or false. So in the case of selection, if the conditional expression evaluates to true, then these commands or command or series of commands is executed, and then the program flow continues from there. If the expression evaluates to false, then a different sequence of commands can be executed, and the code continues from there. For repetition, if the conditional expression evaluates to true, we execute one or more commands, and then we go back and ask again. And if the conditional expression again evaluates to true, then we execute those commands too. And we do this repeatedly in a loop until the conditional expression evaluates to false, and at which case the code continues on to the next command. So sequential execution is straightforward. You execute a command, you go to the next, you execute that, and so on. And both selection and repetition require some conditional expression to make a decision about which commands to execute next. Conditional logic expressions are used to make decisions. These are Boolean expressions, meaning that they evaluate to true or false. Boolean expressions can be built using Boolean logic. These kinds of expressions appear in numerous fields of study, including philosophy of logic, Boolean algebra, set theory, database search queries, digital circuit design, electronics engineering, linguistics, and extensively throughout subfields of artificial intelligence. In fact, Boolean expressions are not just present in AI, but are deeply integrated within various subfields like machine learning, natural language processing, and robotics. In decision-making with Boolean conditions, Boolean expressions are created using the terms and, or, and not. These terms are represented by different symbols depending on the field of study, but carry identical or nearly identical meaning. For example, the term and can be represented by the symbols ampersand, which means a bitwise and, double ampersand, which is a logical and, the dot product in linear algebra, and the wedge symbol, which is a logical and, or the word and, or can be represented by a pipe, which is a bitwise or, a double pipe, which is a logical or, a plus sign, representing addition and an arithmetic operation, or the wedge sign, which is a logical or in propositional logic, or the word or. Not can be represented by an exclamation mark, which is a logical not in programming languages, a tilde, which is a bitwise not, and negation, which is a logical not in propositional logic, or the word not. For example, Boolean logic gates in Boolean circuit design have an AND gate, an OR gate, and a NOT gate, and those perform specific functions. These are the truth tables for those Boolean gates. In the AND gate, if both the A and B inputs are true, the output is true. If either or both of the inputs are false, the output is false. The OR design, this truth table says that if both of the inputs are true, the output is true. If both of the inputs are false, the output is false. But if the inputs are different, true, false, or false, true, then the output is true. There's also a not table, which simply negates the input. So if the input is true, the output is false. If the input is false, the output is true. An example Boolean expression can be seen in a board game where a survivor can only safely attack a zombie if one of these conditions is true. The survivor has a melee weapon, or the survivor has a ranged weapon and that weapon has a range of 0, and there are no other survivors in the room. We can create conditional expressions around these conditions. Let's let Z represent the case that there is a zombie in the room. M represent the case that the survivor is holding a melee weapon. R, the survivor is holding a ranged weapon with range 0. And S, there is another survivor in the room. Then the Boolean expression is Z and M, or Z and R and not S. So you can see how logical rules can be represented as Boolean expressions, and then those Boolean expressions, which evaluate to true or false, can be used to determine program code flow. It's important to note the order of operations. In Boolean logic, not is evaluated first, followed by and then or, with parentheses used to override this order. Another concept that goes along with this is short-circuit evaluation. Short-circuit evaluation is an optimization technique used in some programming languages for evaluating logical expressions with and or operators. It involves stopping the evaluation of the next operand as soon as the overall result can be determined. For example, using and, if the first operand evaluates to false, you know that the entire expression is guaranteed to be false, so the following operands are not evaluated. In the case of or, if the first operand evaluates to true, then the entire expression is guaranteed to be true, so the following operands are not evaluated. Not all programming languages implement short-circuit evaluation. However, it's a common feature in languages like C, C++, Java, and Python. Now that we have conditional expressions, we can create control structures with them. For example, in the case of selection, a common control structure is the if-then-else statement, which could have multiple else-ifs-thens in the middle. And then there are language-specific cases such as the switch statement and the case statement that also allow us to perform selection. Common control structures for repetition include the for loop and the while loop. And then some language-specific repetition structures like do-while, list comprehension, and map. And of course, with repetition, we always want to be aware of infinite loops while using these constructs, and always ensure there's a stopping condition that will eventually be met. If we look back at the repetition structure, you can see that when the conditional expression is evaluated, when it evaluates to true, these commands are executed, and then the expression is evaluated again. If it evaluates to true again, the commands are executed again, and this will continue repeating for as long as the conditional expression evaluates to true. So a stopping condition would be a condition in which at some point the condition expression is guaranteed to evaluate to false so that we can get out of this loop. Otherwise, your code gets stuck in what we call an infinite loop and runs forever but stops producing outcomes, or continues to produce outcomes in a runaway fashion that you don't want to happen. So we need to be very careful when we use repetition structures that the repetition is guaranteed to eventually evaluate to false. Let's look at some code examples. Here we have code examples using these structures in Python. A similar example in JavaScript and another one in C#. So you can see that these examples are similar, these control structures are similar across different programming languages, and we could add other languages to this, and you'll see a lot of similarities across the languages. For now, let's drop down to the terminal and a text editor and execute some of this Python code. If you want to copy and paste the code to follow along, or just type as we continue. Here I've opened my text editor and my command line so we can start to execute some of these statements. And I'm going to copy and paste some of the code from the web page we were looking at. Let's start with this simple example that takes some input from the user after outputting a statement that says, how many rocks do you have? The input function is a function in Python that allows you to collect user input from the terminal. We're going to take that user input from the terminal, store it in the variable count, and then we're going to typecast it to an int because initially count is going to be read in as a string. Following that, we're going to have a conditional statement. This conditional statement uses a classic if, else structure. And if count is less than or equal to 2, we're going to print, I can carry those in my hands. If count is less than 8, we're going to print, I can carry 2 rocks in my hands and however many are remaining in my backpack. And we get the remaining by taking count and subtracting 2 from it. This specific type of expression is an F-style string in Python that allows us to include variables and some simple math and computations within our string by using this notation. With an opening and closing curly brace, everything in there inside those curly braces gets evaluated, cast to a string, and then added to our output string. And then a final else statement is executed if the first if statement is false, and then the second else if statement is false. The final else statement will execute and print a statement, I'm a little robot, I cannot carry that many rocks. So you can see from the decision structure here that whatever the user enters, if they enter a number that is less than or equal to 2, the robot can carry those many rocks. Or if they enter a number that is greater than 2 but still less than 8, the robot says he can carry 2 rocks in his hands and the rest in his backpack. Else, the robot says he cannot carry the rocks. So let's execute this code, which I have saved as temp.py. So I'm going to go to my terminal and execute the code. And it outputs how many rocks do you have. So we see that in our first line here. So I'm going to type a number. Let's start with 1. 1 is less than or equal to 2, so the program prints I can carry those in my hands. And then, of course, since that if statement evaluated to true, we then exit the entire if-else decision structure and move on to the next line of code. And in this case, there is no next line of code, so the program stops executing. We can run it again to test the other values. If we input the value 4, we get I can carry 2 rocks in my hands and 2 in my backpack. So you see that we entered 4, and the print statement says I can carry 2, and then it takes the count that we entered, which was 4, subtracts 2 from it, and outputs that number as part of the string. Let's test our final one. So we have if count is less than or equal to 2, or if count is less than 8. Let's make count equal 8, and we expect our final else statement to execute. And we see that it does. I am a little robot, I cannot carry that many rocks. So that is an example of using a if-else construct for a conditional. Let's look at another example. Go ahead and delete this and copy the next example from our web page. And now we're going to use some new functions. We're going to use our input function again. So we'll first output, is this food? We will read the input into the variable food. And then we'll output a statement that says, I, able, eat this. And so able is going to be a statement that is conditional depending on what the user's input was. So how are we building that statement? I'm setting able equal to the word can, and then I have a single line if statement. So this is a shorthand notation for an if-else statement in Python. And this statement will evaluate to true or false. The conditional part of the statement, rather, will evaluate to true or false, and the conditional part of the statement is food.lower. So I'm taking the input that I stored in food, I'm making it lowercase, and I'm checking to see if it starts with a Y. So we're making a lot of assumptions here. We're assuming that the user is going to respond with yes or no to the question, is this food? Of course, that's making a lot of assumptions, and we should really provide the user with more information. But for the sake of demonstrating an if-else statement on a single line, let's assume that the user is going to enter a simple yes or no. And if food.lower starts with Y, we assume the user entered yes, and we set able equal to can. Otherwise, or else, we set able equal to cannot. So this entire line of code is evaluating an if-else statement and determining how that able variable is going to be set as can or cannot, depending on the user's input. So let's run that and see what that looks like. Go ahead and clear the screen from our previous test. And we will execute our Python code. Looks like I didn't save it. It's still executing the prior code. So we'll go ahead and run that through. Need to go back over here and save the changes that I made. Clear the screen again and execute the new code. So is this food? So if the user enters anything that starts with a Y, we're going to assume the user said yes. And you can see the output with a Y is I can eat this. And so this if statement evaluated, and if food.lower starts with Y, and it does, able got set equal to can. Try it again. Say no, and it outputs I cannot eat this. So you can test this for different values and case, because we are setting the input to lowercase, whether or not the user uses uppercase or lowercase, our code still executes properly, but of course we haven't really tested, so the user could say anything that starts with a W, and apologies, anything that starts with a W, and it's going to say I can eat this. So that's another example of how you can build an if-then statement in Python. If you are using Python greater than or equal to 3.10, there is also a switch or case statement which was introduced to the language. This type of statement is also present in other programming languages. Here we're asking the user what season is it, And here we are taking that input. So this first line up to the dot is going to read in the user's input and resolve to a string. Here, I'm going to immediately take that string and make it lowercase. Store it in the variable season. And then we have this conditional expression that says match season. And in the case that season is winter, print I do not like the code. In the case that it is spring, print something else. First, there's a case for summer, there's a case for fall, and then there's a default case. Should none of these other cases evaluate to true, the default case will execute. So in this type of statement, exactly one of these cases will execute. It will either execute on a matching case, if there is a match, or it will execute the default case. So we can run this. I'm going to clear the screen again, and then execute the code. What season is it? Again, because I am casting my input to lowercase, I can use any case when I answer this. If I say winter, then the first case statement executes and prints I do not like the code. And we can test this for all cases. Let's do fall. The output is, can I be a cat for Halloween? And let's go ahead and test for a case where we didn't enter winter, spring, summer, or fall. And we get the output, the default output as expected. I do not know that season. So that's an example of another selection structure that is available in Python if you are using a Python version greater than or equal to 3.10. So those are some examples of selection structures. Let's look at some examples of repetition structures. The first one being the while loop. So we have a variable x that we set equal to 3. And we're going to say while x is greater than 0, which initially it is because we set it equal to 3. We're going to print while loop followed by the number. Notice here I didn't use an if statement. I certainly could have used an if statement for this output, but I wanted to demonstrate another way to include multiple values in a print statement in Python. And when you include the values as a list in this way, each of those values is going to be separated by a space in the final output. Now, we said about repetition and loops that we want to be sure that the conditional expression ultimately is guaranteed to evaluate to false, otherwise we get stuck in an infinite loop situation. Here, each time the loop executes, I'm going to print a statement, and then I'm going to decrement the value of x. So minus equals in Python is a decrement operator, which is going to decrement x by whatever value I put here, and here I put 1. So we expect this to output 3 the first time it executes, and then x is going to be decremented by 1, becoming 2, and so then it will print 2, and then x is decremented to 1, and we print 1, and then x is decremented to 0, and at that point, x is not greater than 0, so the conditional expression evaluates to false, and we drop out of the while loop into the rest of the code. So we can run this test, clear the screen, and we see we print while loop 3, 2, 1, exactly as expected. Look at another example. Some languages have what is called a do-while loop, and a do-while loop is one where we ensure that the loop executes at least one time We can emulate this in Python. Python doesn't specifically have a do-while loop, but we can emulate it. Here I have a variable playing that I have set equal to true, and then I have said while playing. So playing was explicitly set equal to true. So while true is always going to be true until I explicitly set playing to false. So this will certainly execute at least one time, which is what we want for a do-while type of loop construct. And it's going to output what do you want to hear, save that input to the song variable, and if the user has input stop, we are going to set playing to false. Otherwise, we're going to print now playing the song. So you can imagine that this construct can be used in a jukebox, for example, to continue playing songs for as long as the user is inputting new options until the user says stop. We can run this code. What do you want to hear? We'll put in a song name, and then it says now playing, and then the while loop continues, asking me what I want to hear. So I can continue entering song names until I'm done playing songs, and then I can simply say stop. When the user inputs stop, playing gets set to false, and the while loop stops executing. Another construct that is commonly used in programming languages, in addition to the while loop, is a for loop. A for loop is particularly useful for looping over lists or arrays of objects. In Python, here I've set a variable in equal to 5. Python has a built-in command called range, and if you send an argument to range, you are going to create a range of numbers starting from 0 going to the length that you've input. And then the for statement syntax says for I in range. So this is going to iterate through this range, this list, and one at a time store the value in the variable I. And each time this loop executes, I'm going to print for loop followed by whatever value is currently stored in I. So we can quickly run that and see what that output looks like. Note that we certainly could have implemented this with a while loop as well. And we see this outputs for loop 0, 1, 2, 3, 4. So range in, where n equals 5, is going to create a list from 0, and the length of the list will be n, which is 5, so this outputs 0 to 4. I've provided on the website a couple of other examples of looping in Python. So I'm just going to go ahead and copy those and run them. They're available for you on the website for you to copy the code and run yourself. This does a couple of things. Using the for loop in a different syntax format that's available in Python. So if you have a list or array, you can iterate over it using this syntax. For example, a string in Python is simply a list of characters. And if we read in a string, we can iterate over it character by character because a string is just a list of characters. So here, for character in the input string, we're going to output the binary equivalent of the character. And then here in the next example, we're doing the same thing, but using something called list comprehension. So list comprehension is a very powerful way to iterate a list in Python. And the syntax for list comprehension in Python is to create your statement, whatever you want to have executed. And you can say for X in name, so just like we did up here in the for loop, we're now doing the for loop on a single line. And this is going to execute that for loop. It's a single line notation. We call it list comprehension. It's going to execute that for loop and output the, I believe, the same thing. Let's run this and see what this outputs. So this created a list of bits, and then this print statement is going to join that list of bits. And it says here that we're printing, here is your name in a Unicode binary block. And it does that in both cases here. So we should see the same output using two new different forms of a for loop. Again, I forgot to save. So let's do that again. All right, so what is your name? So I can enter a name. For example, I'll just enter Bob. And we see the exact same output twice. So this is Bob in a Unicode binary block. So bits 0 and 1 shown in a block where each row is the Unicode binary form of the character. So capital B followed by O followed by small b. And we get the same output when we do the list comprehension. If you go back to the code, you can see that we have recreated this example in Python and several other programming languages, so you can exit in the other programming languages as well. I used Python here as my favorite programming language to demonstrate the example, but this is a very common type of loop constructs doing selection and repetition across multiple different types of programming languages and other engineering and mathematical tasks.